This is the wiring diagram of the Lafayette guitar amplifier, and there is a link in the show more of this video so you can download this drawing. What I'm showing here is the B+ on the plates of the tube, the DC, and notice the capacitors at the top there. Only one plate I have turned red, and that's because capacitors block DC. So those capacitors keep the B+ from going any further. Now I'm going to be showing the path of the audio, and I'm going to connect a signal generator to one of the inputs, and we can see here that that audio signal has no problem going through the capacitor all the way over on the left, and it ends up on the control grid of the first tube. Now the first tube will amplify this signal, and I'm not showing the amplification, I'm only showing the path of the audio. If I tried to show the amplification, you wouldn't really be able to see anything. And you'll see why when we put an oscilloscope on this. But anyway, you'll see that on the left side, that audio signal travels through the capacitor, and again the DC does not. The B+ stays where it should. And this audio signal, depending on where the tone control is set, if the tone control is closer to the ground, we have more tone, or in other words, less highs, and if it's in the other direction, we have more high frequencies. Now looking at the capacitor on the right side, that signal goes to the volume control, and if the volume control is closer to that capacitor, we have more volume, and if the volume control is set closer to ground, we have less volume. And that signal continues over to the control grid of the next tube. This signal is amplified, and as you can see, it goes through that 0.01 microfarad capacitor and ends up on the control grid of the next tube, which is the output tube, and it amplifies it and sends it over to the output transformer, and that gets magnetically coupled to the secondary of the transformer and then drives the speaker. But notice on the secondary transformer there is no DC. It is audio only. Now I'm going to set this up with a signal generator and an oscilloscope so we can see how the tubes amplify the signal and also the phasing of the signal. Now I have the two controls set like this. The tone control is almost off, and the volume control I have set so the volume is not very high at all. Okay, I've got the ground of the scope and the signal generator hooked up right here. And I've got the signal generator input connected to one of the inputs of the amplifier or guitar amplifier. And here is pin 1. Okay. I'm going to change the setup on the scope so we can see the phasing. Pin 1. There we go. And of course it would have to be in phase. Okay. Here is pin 7. Okay, now it went off the screen because there's a lot of DC voltage there. You can see there's quite a bit of amplification in that one tube. Let me turn down the scope on channel 1 here. A couple of clicks. And see if we can't see that. There we go. And we can clearly see that it is 180 degrees out of phase. Okay. Here is pin 1 of the next tube. Okay, still out of phase, and it's quite a bit less in volume because I've got the volume control turned down. Okay, now here's pin 7, same tube. And again, it's now in phase with the input because we've gone starting in phase, out of phase, in phase again. Okay, now this goes over to pin 1 of the output tube. Okay, still in phase. Okay, now we'll go to the plate of the output tube. Okay, quite a bit of amplification again. Okay, I'm going to have to turn down the scope again. Try one click. Let's see if that'll work. Nope, still too much amplification. One more click. Okay. And here it is. Out of phase, and that rippling there, that's because it's not filtered as good as the front end. It doesn't have that extra filtration on it. And what we're seeing now is the ripple on top of that signal, or a little bit of hum in the speaker is what that amounts to. Thanks for watching.